Greetings, my name is Sanlyn Buxner, and I'm from the University of Arizona in the Planetary Science Institute. And today I'm going to be talking about a project that is led by Kate Follett at Amherst College, many of her students, as well as other collaborators, including Erin Gallion from the University of Arizona. Today, we're going to be talking about what we call the QuaRCS, which is the Quantitative Reasoning for College Science Assessment. And we've been working for a while now on the reliability and validity of this instrument that assesses undergraduate students' knowledge of basic quantitative skills, attitudinal and some affective variables, as well as some context variables, including academic background and student demographics. Additionally, we ask students about the effort they put into the assessment when they take it. We believe that these skills are very important. We'll talk a little bit about this. The original QuaRCS is 25 questions, and the light version is 15 questions. When we look at the types of skills that are being assessed, they are numeracy, quantitative literacy, and quantitative reasoning. The top 5 skills within these domains on the assessment are graph reading, table reading, arithmetic, estimation, and proportional reasoning. Like we said, we think these are important skills for students in their everyday lives. They're really interdisciplinary skills that can be looked at any introductory science course. To give you an idea about what the assessment looks like, here's just a few sample questions. So some examples of students looking and extracting data out of figures, looking at tables, and doing some comparisons to see if they really understand some estimation. We've done regressions to figure out what is accounting for the variance in student outcomes, so how well they do. And in this model, each circle shows you relative to the other circles how much variance is accounted for by such things. And so in this first model, we see that effort accounts for a lot of the variance in the outcomes. We also see these 3 other factors, which we call math relevancy, how important do they believe math is, math anxiety, so how nervous they might be about math, and what we call numerical self-efficacy, so what they think about their own ability in math. And interestingly enough, everything else, including those demographic variables, account for very little of the variance. To give you an idea, here's a graph. We talked about effort. If you look at student self-report, if they say they had low effort, they just clicked through, on average, they do quite poor on the assessment. And if they say they tried their best, well, we see a much larger score. And so we know that these other variables have a lot to do with outcomes. Recently, Kate's students have started working on some new models and some new items. And so we have a revised model. So again, effort still plays a large role. We see math relevancy and math anxiety, but numerical self-efficacy, the amount of variance there is much smaller because we've added some new factors. And so we have what we call daily life math affect and school math affect. And then the ones along the bottom, which are important in many types of studies. And so including things like growth mindsets, right? Do they believe that they can be smarter in math? Metacognition, their own awareness of how they learn and how we get smarter, as well as a sense of belonging. And so taken together, this is work we're really excited about, revising the model and better understanding what can lead to not only better scores, but supporting students and giving some suggestions to instructors. Recently, we have been trying to increase the cultural relevancy of the assessment. And so this is what it looked like. We asked students to answer the question and then afterwards asked them how confident they were in their answer. And then also how much that answer resonated with them in their life and their identity. This was done through some surveys and focus groups and did lead to some revisions in the items. And here's such an example of some revision. And so over here, the old item really talked about a homeowner looking at installing solar panels on their own home and having them figure out the area they might need. To over here on the right, saying that you are a solar panel installer, which resonates probably more with where students are in their lives. And really thinking about, again, the area that they need to have for their client for the solar panels that they need to install. When we look at the overall study, our take-home messages are this. We know from our studies and others that negative attitudes towards math is a persistent issue in college students. And so something we all just need to be aware of. But we know that those attitudes towards math matter way more to student performance than their demographic characteristics. And so again, something very important for us as instructors and researchers to attend to. In the studies that we have done, if we account for these affective variables, they're going to reduce what we might have seen in observed achievement gaps between underrepresented groups and majority groups. And so we know that the achievement gaps are entangled with the affective measures, telling us it's not about student demographics per se, but really about how these affective variables play out. Now, the story about which affective variables are the most important, have the most explanatory power, actually varies between students of different backgrounds. And so we can't just say this is really important and this one is not. And so we're really interested in figuring out multiple ways of supporting students. We know that introductory astronomy, as well as other science courses, are places to change attitudes. And we believe that these are places to change overall quantitative literacy skills. And so we really are going to carefully consider how to help students reduce math anxiety, improve their self-efficacy, and hopefully see the utility of math, that relevancy in our courses. And we know that it will likely be impactful for all students, especially those from minoritized groups. Our upcoming work will be testing the revisions of those new cultural relevancy items to see if it is performing well with a variety of students. And we are going to have some faculty learning communities about supporting students in their quantitative literacy. So look for that. And we invite you to get involved. So if you would like to administer the QuaRCS in your undergraduate class, you will receive pre and post semester reports about how your students are doing in aggregate. We do not show off any student identity, so you'll see your whole class. You'll also have a report summarizing your students' skills and attitudes. If you are interested, please reach out to Kate. Her email is here, and we would love to have you involved in our study. With that, I just want to acknowledge our funding from the National Science Foundation, and we're very grateful for that support and want to thank you, and I look forward to our discussion.